The Sun. The star of our solar system. This big, hot ball of mostly hydrogen and helium gases is the most massive and the most influential thing in our planetary system. It is 1.4 million kilometers across in diameter. That is more than 109 times the diameter of the Earth, and it is so massive that 1.3 million Earths could fit inside it. At its core, temperatures can reach 15 million degrees Celsius. This is also where energy is created in the Sun through the process of nuclear fusion. Through this process, two hydrogen atoms fuse together to create a helium atom. This process releases a lot of energy as a byproduct. As billions upon billions of hydrogen atoms go through this fusion process, a colossal amount of energy is produced on the Sun. This energy eventually reaches the Earth as solar radiation. From the Sun to our planet, solar radiation covers a distance of 150 million kilometers through space within just 8 minutes. This solar radiation is extremely important for all life on Earth. Without the Sun's heat and light, the Earth would be a dark, cold, and an uninhabitable place. The Sun warms our seas, stirs our atmosphere, generates our weather patterns, and gives energy to the plants that form the basis of the food web on the Earth. These same plants use the energy of the Sun to generate oxygen, a gas that is vital for the survival of humans as well as numerous other life forms on our planet. The Earth itself is at an optimum distance from the Sun, well within what we call the habitable zone or Goldilocks zone of our solar system. This allows the Earth to support liquid water, one of the known necessary requirements for life. If the Earth was too close to the Sun, it would be just too warm to support liquid water, as we see in the case of Venus. If it was too far from the Sun, it would be just too cold, and all the water would just freeze over and turn into ice. However, even with this, the Earth would not be a very comfortable place to live in if it wasn't for our atmosphere, which plays a central role in how solar radiation interacts with our planet. To understand this, we do not have to look any further than our moon. The moon and the Earth are almost at the same distance from the Sun, and thus they receive almost the same amount of solar radiation. However, while the average temperature on Earth is 16 degrees Celsius, on the moon it is minus 80 degrees Celsius. This difference exists solely because of the Earth's atmosphere. The atmosphere of Earth is a thin layer of gases, what we call air, that surrounds our planet. While technically the Earth's atmosphere is about 480 kilometers thick, most of it actually lies within just 16 kilometers from the Earth's surface. The Earth's atmosphere protects us from a lot of the Sun's dangerous rays, but it also traps some of the solar radiation from the Sun that is able to get through it, especially infrared radiation or heat. This is also the reason why at night temperatures do not fall so drastically on our planet, and why the variation between daytime temperatures and nighttime temperatures is not too much. To understand how the atmosphere is able to capture heat from the Sun, we have to look at its makeup. Nitrogen is the most abundant gas in our atmosphere, making up for 78% of its composition. Then comes oxygen at 21%, followed by argon at 0.93%, and carbon dioxide at 0.04%. Trace amounts of some other gases are also present in the atmosphere, like neon, helium, methane, krypton, hydrogen, and water vapor. Even though in small quantities, the presence in our atmosphere of gases like carbon dioxide, methane, and water vapor plays a central role in keeping our planet warm through a natural process called the greenhouse effect. This is also why these gases are called greenhouse gases. So now the question arises, what is this process called the greenhouse effect? To understand the greenhouse effect, we have to look at how solar radiation interacts with our planet's atmosphere. Roughly 70% of the solar radiation that reaches the Earth is absorbed by Earth's oceans, land, and atmosphere, while the remaining 30% is immediately reflected back into space. As the planet's surface heats up, it emits infrared radiation or heat. Some of this heat passes through the atmosphere back into space. But most of this heat is absorbed and emitted in all directions by molecules of the greenhouse gases present in our atmosphere. Owing to this, the Earth's surface and the lower levels of our atmosphere further warm up, in turn raising Earth's overall temperature. This is what we call the greenhouse effect. You can also try to understand the greenhouse effect in another way. Imagine it's a warm, sunny day, and you draw the curtains from the glass windows in your house. Soon, the temperature of your room will start to increase. What is happening here is that the glass is trapping heat from the sun, thus increasing the temperature of the room. When it comes to our planet, the atmosphere is very similar to the glass on your window. In a similar fashion, it is trapping heat from the sun inside of it, and the greenhouse gases are helping it enormously in doing so. Greenhouse gases include several naturally occurring molecules, like carbon dioxide, water vapor, methane, nitrous oxide, and ozone, as well as several manufactured ones, like chlorofluorocarbons or CFCs. Overall, the greenhouse effect is an important natural process that makes the Earth habitable. But today, it is exactly this process which has become a cause of concern for humanity globally. At the heart of the problem are two things: humanity's thirst for energy and humanity's blatant disregard for the fine natural balances that nature maintains on our planet. Since time immemorial, humans had very limited sources of energy available to them. They either used their own muscle power, the muscle power of their domesticated animals, or they simply burnt wood for energy purposes. The energy in all these cases came from the plants which we ate, or our domesticated animals ate, or the plants which we cut down for wood. And the plants themselves got this energy from the sun. In this way, all life operated within the fairly immediate flow of energy from the sun to the earth. But almost 270 years ago, all this began to change after the start of the Industrial Revolution. Starting in 1750 and slowly progressing to transform human civilization by the 1900s, the Industrial Revolution has had a profound effect on all of our lives. The world we see around us, from its political borders to its engineering and technological marvels, all have been possible because of the Industrial Revolution. Within just 2 centuries, the Industrial Revolution led to a significant increase in the standard of living for many people in the Western world. With the sustained economic growth that the Industrial Revolution unleashed on the world, a new middle class was born. At the same time, the Industrial Revolution transformed the very nature of work, and it kick-started a new capitalist way of exploitation of the labor of the working classes. A new class struggle was thus born, a struggle we see continuing to this very day in our world. As production boomed in the Western world, the demand for resources and new markets started the process of colonization on our planet. Hundreds of millions were subjugated and forced into abject poverty so that the fruits of industrial and economic progress could continue to be enjoyed in the Western world. But before the Industrial Revolution started transforming all of our lives, no matter where we lived on the planet, it transformed the way humans consumed energy. In fact, it is this very change that made the Industrial Revolution possible in the first place, and without which our modern civilization would not exist. This historic change in energy consumption was only made possible thanks to fossil fuels: coal, oil, and natural gas. Fossil fuels formed 360 to 286 million years ago in an era known to us as the Carboniferous period. At that time, the land on our Earth was mostly covered in swamps filled with various kinds of ancient plants and organisms. Over time, as these plants and organisms died, they sank to the bottom of swamps and oceans. Over millions of years, their decomposed remains got covered under layers of sand and clay and other minerals. These layers compressed these remains to form a mineral called kerogen. Geothermal heat then slowly transformed this kerogen into fossil fuels, with some types of kerogen transforming into coal, while others got transformed into oil or natural gas. These three fossil fuels powered the Industrial Revolution, and they continue to power and shape our world of today. At first, the Industrial Revolution was driven mainly by coal, with the use of oil and natural gas only picking up around the 1900s. While humans had mined and used coal for centuries before the Industrial Revolution, the scale of this use was very limited. Starting with the invention of the steam engine around the beginning of the 18th century, the use of coal only kept increasing with every passing year. In fact, the steam engine itself was invented to make the process of mining coal easier. As newer and newer machines were designed and built, coal became our preferred source of energy to power them. Slowly and steadily, as the Industrial Revolution spread around the world, with new technologies being discovered, technologies like electricity and telegraph communications, coal became a major source of energy for entire humanity. In time, we discovered how to make use of other fossil fuels like oil and natural gas. The internal combustion engine allowed us to use oil to transform our means of transportation. Soon, fossil fuels helped us transform agriculture. No longer did farmers need to solely rely on manual or animal labor to work their fields. Tractors and other machines revolutionized the agricultural sector, thus increasing global food production. Using these fossil fuels, we then created new kinds of fertilizers, thus further enhancing global food production many folds. The more food we produced, the more mouths we could feed. Human population boomed across the planet. Today, fossil fuels are everywhere. They are a central pillar to our modern lives, and it would not be wrong to say that humanity today is completely addicted to them. We need them for our cars, aircraft, and ships. We need them to produce plastics, synthetic fibers, detergents, cosmetics, and medicines. They are even needed to produce important materials like glass, cement, and steel. The situation is such that since the year 1800, the global consumption of fossil fuels has increased by more than 1300 times. That is 1300 times in just 220 years or so. You can better understand this growth by having a look at this graph. This graph depicts the global primary energy consumption measured in terawatt hours on a yearly basis. As you can see, in the year 1800, global fossil fuel consumption was almost zero. By 2017, it had increased massively, standing at more than 133,000 terawatt hours. This upward trend continues to this very day. Now, of course, owing to the corona crisis of last year, that is the year 2020, we did initially see a decline in global fossil fuel consumption. But now, as things are heading back to normalcy, Global fossil fuel consumption is once again following the original upward trend. This rise in consumption of fossil fuels, as seen in this graph, has come at a cost, a rather massive cost. The Industrial Revolution and the widespread use of fossil fuels led to massive amounts of environmental degradation, from our polluted air, to our polluted rivers, to the loss of vast swaths of forests around the world. It's a cost we are still living with. But by far, the biggest damage widespread fossil fuel use has done to the planet is something perhaps worse than all of this. Something that is now affecting the very natural processes of our Earth. The same processes that make it possible for life to exist here. The future of all life on Earth, humans included, is now in peril owing to our widespread use of fossil fuels. You see, when we burn fossil fuels, they release carbon dioxide and other greenhouse gases into our atmosphere. As explained earlier, these gases have a role to play in warming up the planet. Out of all the greenhouse gases, carbon dioxide is considered to be the most important, and it is emitted because of both natural and human causes. But today, most of the carbon dioxide emissions come from burning fossil fuels for energy. Now here is a graph that shows us historic carbon dioxide levels in the atmosphere over the past 800,000 years. The year 0 here stands for the year 1950. 800,000 means 800,000 years before 1950. On the left side, you can see the carbon dioxide level in the atmosphere, measured in parts per million or ppm. Historically, carbon dioxide levels in the atmosphere definitely had their ups and downs, and this was all because of various natural processes. However, as you can see in this graph, starting around the year 1950, carbon dioxide levels in the atmosphere started skyrocketing. In fact, these levels have increased by more than 40% since the start of the Industrial Revolution, from roughly 280 parts per million to more than 400 parts per million today. For millennia, atmospheric carbon dioxide levels have never been this high on our planet. In this graph itself, you can see that carbon dioxide levels have never gone beyond this particular line, which basically means that over the last 800,000 years or so, these levels have never risen beyond 300 ppm. We today clearly know that this buildup of carbon dioxide is a direct result of human activities, the widespread use of fossil fuels included. Owing to the greenhouse effect, this buildup of carbon dioxide as well as other greenhouse gases in our atmosphere has led to an increased amount of warming of our planet, way higher than what one could expect to occur naturally. This is what we call global warming. As per the American Space Agency NASA, global warming is the long-term heating of the Earth's climate system, observed since the pre-industrial period due to human activities, primarily fossil fuel burning, which increases heat-trapping greenhouse gas levels in the Earth's atmosphere. To understand global warming, we have to look at this next graph. This graph illustrates the change in global surface temperature relative to the 1951 to 1980 average temperatures. The 1951 to 1980 average temperatures have been used to create what we call a long-term global average temperature, and are basically used here as a reference value. The left axis of this graph shows the deviation in global surface temperature relative to this reference value. Hence, minus 0.5 implies a decrease of 0.5 degrees Celsius in comparison to our reference value, and 1.5 implies an increase of 1.5 degrees Celsius over our reference value. The bottom axis of this graph represents the year. Since the pre-industrial period, human activities are estimated to have increased Earth's global average temperature by about 1 degree Celsius. Things have only gotten far worse since the 1950s, when global fossil fuel use really picked up. Today the condition is such that 20 of the warmest years ever recorded have all been recorded since the year 2001. The year 2016 ranks as the warmest year on record, followed by the year 2020 as the second warmest year on record. And as far as the future is concerned, things are only predicted to get far worse. As per the annual emissions gap report published by the United Nations Environment Programme in November 2019, the world is heading for a 3.2 degrees Celsius global temperature rise over pre-industrial levels by the end of this century. That is by the year 2100. That is a 3.2 degrees Celsius rise even after taking into account humanity's current efforts in decreasing its greenhouse gas emissions. Today, global warming is proceeding at an unprecedented rate. It has in turn initiated a long-term change in the average weather patterns that have come to define Earth's local, regional, and global climates. This is what we call climate change. While natural processes can also contribute to climate change, today we are certain that the climate change we are witnessing is a direct result of human activity, mainly the burning of fossil fuels, but also intensive agriculture, livestock raising, and land clearing. The effects of climate change on our planet are numerous, and the scientific community is still discovering new facets to this problem. The more we learn, the more we understand how challenging this problem is for humanity. In fact, today with whatever we already do know, we can definitely say that climate change is perhaps the biggest challenge humanity has ever faced in all its time on Earth. In the coming decades, climate change is expected to harm human health, increase droughts, contribute to sea level rise, and decrease national security and economic well-being throughout the world. It is a massive tragedy that is coming for our human civilization. And the so-called guardians of that civilization, the politicians we look up to for finding solutions to crises like these, they very much prefer that we remain entangled in issues that belong in the Middle Ages. They do not want you to think or discuss, or worse, pressure them about an issue like climate change. Hence, it is important that we stop wasting our energies playing their power games. Climate change will not care which religion or caste or nationality you belong to, but will affect all of us irrespective of that. To fight against it, we all will have to stand together. Without this national and international solidarity, the coming fight against climate change will only end in defeat. United we stand, divided we fall. Climate change is an issue of utmost importance, and time is not on our side. Climate change is no longer something that will occur in the future. It is here. Its effects are already becoming visible, and it is already having a profound effect on all life on Earth, humans included. To face this challenge of climate change and to understand its seriousness, it is important that we first inform ourselves about this crisis. And really, this is an effort that we ourselves will have to undertake, since one of our primary sources of information in this day and age in our country, the Indian mass media, has absolutely no time to discuss this life and death issue, no matter even if the future of our country, of the entire human race, depends on it. Think about it. When was the last time you saw this media discuss any environmental issue? Forget climate change for a moment. If you set aside a few media outlets, there is absolutely no hope that this media will play any positive role in informing the people of our country about global warming and climate change. This channel is a small contribution to fill exactly this information gap around climate change. In our upcoming videos, we will show you how our world, this planet, which is the only home we have known, is now changing. From its ice sheets to to its oceans, from its mountains to its forests. Change is already in motion. This is our changing world. We will soon return with our next video. Please do not forget to subscribe to our channel.